Hey everybody, we are back with another video on the power of skip counting. And yes, you read the title right. Skip counting can help you with division. To help you better understand why it works the way it does, I want to go back and talk about multiplication, which I discussed in the last video. There are components of multiplication and division that are very similar because they are called inverse operations, which is a fancy math term to say opposites. To help you better understand their inverse relationship, I want to go over the parts of both multiplication and division problems. Starting with multiplication, the first two numbers in a multiplication fact are factors. The first factor represents the number of groups. The second factor represents the number of objects in each group. The last part of a multiplication fact is called the product. The product of a multiplication fact represents the total. Division problems have those same three components, just with different names. For example, the first part of a division problem is called the dividend. A dividend represents a total. The second number in a division problem is called the divisor. A divisor is a number that represents how you will be dividing the total. The last portion of a division problem is its answer, which is called a quotient. Now notice I have not put a description under the word divisor or the word quotient. The reason for that is because the role that these two play is based off of how you're using the divisor. And what I mean by that is this. In some cases, the divisor can be represented by the number of groups. And this is where you will be sharing a set equally. So if my divisor is the number of groups, my quotient will be represented by the number in each group. In taking away equal sets, you're taking away by the number that's in each group. So sometimes the divisor can represent the number in each group. In that case, if the divisor represents the number in each group, my quotient is going to represent the number of groups. As you can see, it still has the same two parts, the groups and the number in each group like multiplication. The groups and the number in each group like multiplication, but they're interchangeable depending on how you use the divisor. Also notice that in multiplication, we are working these factors, these groups and the number in each group to find a total. So the total is not given to you. Whereas in division, it's the very first part of a division problem. That is why they're inverse operations. With multiplying, you're putting groups together, groups of objects together to create a total. Whereas in division, you have a total already. You're separating that total in some way, whether it's groups or by what's in each group. Now, let's take what we've learned here and connect it to how we're going to use our power of skip counting in combination with our fingers to come up with the answer to division problems. Say for instance, we are presented with this scenario of 6 divided by 2. As we discussed, the 6 is our dividend or our total. But for the purpose of our power and skip counting, the 6 is going to represent what we say. Our second part of the division problem is our divisor. And the divisor is going to tell us what we are skip counting by. So what song will we use to help us in solving? Now remember, there's not a song for every single thing that we count by, because some of those things students come into third grade already learning how to do. Those 1s, the 2s, the 5s, and the 10s. Okay, now for the last piece of our division problem. As we talked about, it represents the quotient. That is the answer to a division problem. But in our case, the quotient is going to be represented by how many fingers we have up. Now, when you do this process, you are actually using the equal groups method that I've listed in the What's the Move division video. If you have not had a chance to look over those videos and just see the different ways that you can represent division, I highly recommend you go and look at it. We're going to be, instead of doing the equal groups on paper, we're going to be using our fingers in the same way. So I'm going to be counting by 2 until I say 6. So if I count by 2 until I say 6, that's going to be 2, 4, 6. How many fingers do I have up? 3. So my quotient, my answer to this division problem is 3. Let's try another one. This division fact says 15 divided by 3. Let's review how we're going to use each of the parts. My 15 is my dividend or total. That is going to be represented by what I say. My divisor of 3 is going to represent what I count by, or what song I use to help me skip count. Lastly, my quotient, or my answer to a division problem, is going to be represented by how many fingers I have up when I count by 3s and stop when I say 15. Counting by 3s until I say 15. For this, we will need our 3 song. Three, 6, 9, 12, 15. How many fingers do I have up when I count by 3s and stop when I say 15? You said 5, you're correct. Therefore, my quotient in this case is represented by the number 5. Let's try another problem. This one says 32 divided by 4. Starting with our dividend of 32, that will be represented by what we say. Our divisor of 4 will be represented by what skip counting song we use, or what we're counting by. Lastly, my quotient, or my answer to this division problem, will be represented by how many fingers I have up. So since my dividend or total is a little bit bigger, I'm going to have both hands handy. I'm going to count by 4 till I say 32. using my fingers, that would be 4, 8, 12, 16, 20, 24, 28, 32. My quotient is found in how many fingers I have up. How many fingers do I have up? I have 8 fingers up. So my quotient for this problem is 8. When I count by fours until I say 32, I get a quotient of 8. Let's try another one. We have 54 divided by 6. Starting with our dividend of 54, it is going to be represented by what we say. Next, our divisor of 6 is going to be represented by our skip counting song of 6s. Lastly, our quotient will be revealed to us by the number of fingers we have up. So we are going to count by 6 until we say 54. That would be 6, 12, 18, 24, 30, 36, 42, and 48, 54. My quotient can be found by how many fingers I have up. Number of fingers I have up is 9. Therefore, my quotient of 54 divided by 6 is 9. Let's try one more. We have 49 divided by 7. Starting with 49, our dividend. That number represents what we say. Our divisor of 7 represents what we count by. In this case, because we have a skip counting song by 7s, it's going to be the song that we sing. Lastly, my quotient, which is what I get when I divide 49 by 7, is going to be represented by the number of fingers I have up. I'm going to get my quotient when I count by 7 until I say 49. Let's do that using our 7 song. 7, 14, 21, 28, 35, 42, 49. My fingers tell my quotient. The number of fingers I have up is 7. So the quotient of 49 and 7 is 7. As you guys can see from practicing this, the ways we multiply and divide are very similar. I've enjoyed showing you all how powerful skip counting can be. Let me know what you guys think about this in the comments. As always, everybody take care.